All right, welcome to our review over our transformations unit. So we're going to start off with this quadratic. Notice the vertex here is at 4, -3. We use our pattern of up 1 over 1, over 2 up 4, if we have enough room, over 3 up 9. Remember, these are symmetrical, so we can flip them over, connect our dots, and then we graph it. So our domain is always all real numbers. Now our range with this one opening up would be y is greater than or equal to -3. So the x-intercepts, we're going to have to plug in 0 for y and solve for our actual x-intercepts since they do not cross at a nice, neat point. So the first thing we'd want to do is add 3 to both sides. And now we need to get rid of the square. So we're going to take the square root of both sides, and we'll have a positive negative radical 3 is equal to x minus 4. So now we just got to add 4 to both sides. And there we have our exact values for x-intercepts. So the one on the left is 4 minus radical 3, and the one on the right is 4 plus radical 3. Now the y-intercept, since we can't see it, we should just go ahead and plug in 0 for x and work it out. So when we plug in 0 for x, notice we'll have a -4 squared. So -4 squared is positive 16. So then we just have 16 minus 3, and we get the value of 13. So we know that our y-intercept is at 0, 13. All right, so with this problem, notice we have a stretch factor of 2, so we're going to have to do things a little differently. Our vertex is located at -1, -4. So remember, inside lies, the outside tells the truth. And we use our stretch factor to go over 1 up 2. Then we'll go over 2 up 8. And that's all the points we can plot. Connect our dots. Again, our domain is all real numbers. The range, since it's opening up, is y is greater than or equal to -4, the k value. And our x-intercepts we're not going to worry about on this problem. And the y-intercept, we can see that we're at 0, -2. All right, so this one has a stretch factor of -1/2. So we are going to be opening our quadratic down when we graph it. Our vertex is at -2, positive 2. And we go over 1, down 1/2. Then we go over 2, down 2. Connect our dots. So remember, we multiply our vertical movements by the a value. Our domain is all real numbers. The range is y is less than or equal to 2, since opening down. And our x-intercepts, we plotted them. So we can see -4, 0, and 0, 0, the origin. And our y-intercept is also at the origin. All right, so this one has a stretch factor of -2. So our vertex is located at -1, -3. And from this point, we need to go over 1, down 2. And then we need to go over 2, down 8. And our domain's all real numbers. Range is y is less than or equal to -3. Since opening down, it's less than or equal to. X-intercepts, we don't have any. And we've talked about solving for the complex solutions, but we're not worrying about that right now. And our y-intercept is at 0, -5. We plotted it. All right, so on absolute values. So we got to make sure, remember that absolute values should make something that looks like a V and not a U. So this guy is opening down because it's got a negative stretch factor. And so we go from our vertex of 1, 4, we just go down 1 over 1, down 1 over 1. And then we connect our dots. So our domain, just like with quadratics, is all real numbers. The range is y is less than or equal to 4. X-intercepts we plotted, -3, 0, and 5, 0. And then the y-intercept is 0, 3. All right, so this absolute value is opening up, and our vertex is at +2, +3. And then our slope is like 1, so we go up 1 over 1. And we flip those points over. And our domain is all real numbers. Since it's opening up, our range is going to be y is greater than or equal to 3. We do not have any x-intercepts. And our y-intercept is at 0, 5. All right, so with this one, we need to go back 3 and up 1 to find our vertex point. And then now we got -3, so we got to go down 3 over 1. And then we have to flip these points over, connect our dots, get our domain, all real numbers. The range will be y is less than or equal to 1. And our x-intercepts, if we got a slope of 3, we know when we go down 1, we're going over by 1/3. So we would have x-intercepts at -2 and 2/3. And we would have another x-intercept at -3 and 1/3. Our y-intercept we can't see, so we're going to plug in 0 for x and just see what we actually get out. So we plug in 0. We end up with -3 times the absolute value of 3, which is -9. And then -9 plus 1 is -8. So our y-intercept is at 0 and -8. Being lazy. So we're going to skip that one, just like the other ones. All right, so circles. Remember, circles, the x and the y value of the center lie. So our center is at -3, -1, and we have to take square root of 4 to get 2. So our radius is 2. So we put our center at -3, -1, and we draw, 2 units out in each direction, and then we just do the best we can at drawing a circle. Same thing here, we're going to skip it the same. All right, so let's talk about completing the square here so we can actually get it into our graphing form. So we need to group everything together. So I'm going to get the constant term to the other side as well. So now we just have to take half of our b value, square it, and add it to both sides. So half of 2, well, don't know what happened there. Give me 1 second. Half of 2 is 1. And 1 squared is 1. So we need to add 1 to both sides for our c value for the, there we go, and then same thing for y. So now we know this thing factors to x plus 1 squared plus quantity y plus 1 squared equals 9. So we know that our vertex is, I'm sorry, not our vertex, our center is located at -1, -1. And then we need to go out 3 units in each direction and draw our circle. All right, so let's graph a square root function. I'm going to get the k value to the right side so everything follows how we talked about it. So we know our starting point here would be back 3, down 3. And we're going to go over 1, up 1, over 4, up 2, and then over 9, up 3. Remember, we take the square root of our horizontal movement to get our vertical movement. So our domain would be x is greater than or equal to -3, and our range would be y is greater than or equal to -3. All right, so with this one, our starting point would be at -4, +1. And we have a stretch factor of -2. So when we go over 1, we're going to have to go down 2. Then when we go over 4, we're going to have to go down 4. Then when we go over 9, we're going to have to go down 6. So our domain stays the same, be x is greater than or equal to -4. But since this one's going down with the range, we need to say y is less than or equal to 1. All right, so with this one, I'm going to do number 16 here, and because we did number 15 in class. So since this has a -a value, we are going to have to do a little bit of work. But I'm going to get the constant value to the other side and have my -x squared plus 20x over here. So now I need to factor out that -1 out of the right side. So when I factor that out, I have a and then x squared minus 20x. So now we have to complete square. Half of negative 20 squared is 100, so we're going to add 100. But now I have to take 100 times that negative 1, so that means we're going to subtract 100 from both sides. So we have a y minus 5 equals x squared minus 20x plus 100, which factors to negative x minus 10 squared. Add 5 to both sides, and we've got it in vertex form. The vertex is at 10, 5. All right, so let's write an equation of a circle. Remember, inside lies, so it'd be x plus 10 squared plus y plus 12 squared equals 9. Then for 18, we'd have x plus 13 squared plus y plus 3 squared, and then the square root of 13 squared is just 13, so it would all equal 13. So if you watch this video, let me know in the morning, and it might be worth something on our test. All right, have a great night.